sends the interrupt request signal to the microprocessor. So these are the things we have seen, and we have some specific ports for port A and port B for exchanging the handshaking signals. And here you can see that port A with the port A we have connected one input device, that is the keyboard. With port B we have connected one output device, that is the 7-segment display. And initially for collecting the input, the port C is used. You see through port C's pin number 2, the strobe signal is sent, and in reply to that, through pin number 1 of port C, the input buffer full signal is sent, and afterwards the data will be collected by the 8155 using the port A's 8 pins. And this is the data line actually. And afterwards, the data will be collected by the port A or by the read command or read signal by the microprocessor. And in contrast, for the output operation, the write signal, the microprocessor writes the data into the 8155, and afterwards, through port C's pin number 4, the OBF signal is sent to the output device, and in reply to that, it sends the acknowledgement, and afterwards it collects the 7-segment display collects the data through port B. And you see the port B has total 8 pins. So maximum 8-bit data we can handle here. And another thing is that if the input device needs to send any interrupt request to the microprocessor, in that case, port C's pin number 0 is used, and also the device that is connected in port B, if that device needs to send the interrupt request signal, in that case, port C's pin number 3 is used to send the interrupt request to the microprocessor. So this is how the handshaking modes and 8155 was explained to you in my last class. And thereupon, I will start talking about 8255. And in 8255, this is also programmable peripheral interface. And I have told you that this 8255 is compatible to work with 8086 microprocessor. It's a 40-pin IC. And out of that 40 pin, we have 24 pins, port A, port B, port C. These 3 ports, each having 8 pins. So total 24 pins are used for input-output operations. But in my last class, I have talked about that for exchanging the control signals, likewise the 8155, port C's pins are categorized into 2 parts. One is group A. In the group A, what we have in group A, we have all the 8 pins of port A and the upper 4 pins of port C. Upper 4 pins means PC4 to PC7. And for group B, we have all the pins of port B as well as the lower 4 pins of port C. So this forms the group B. So this is one thing. Another thing is that we can use maximum 8-bit internal data bus, though we know 8086 is a 16-bit microprocessor, but 8255 is a peripheral device or peripheral interface that can deal with maximum 8-bit data. And as usual, we have the read signal, write signal, reset, and A0 and A1 is the control logic to select a specific 8255 interface IC. I will show you today. And you see that this data bus is connected to the 8086 microprocessor. This is the block diagram, and you see this is the pin diagram, and this pin diagram is also described, and you see that all the PA0 to PA7, PA0 from here to here, PA0 to PA7, these 8 pins for port A. Then you see that PB02 PB7, PB0 to PB7, these 8 pins for port B, and PC0 to PC7 that are lying here. These 8 pins for port C. We have two specific pin A0 and A1. I will show you that why do we need A0 and A1 to select in a specific port. So A0 and A1 combinedly provides us 4 options: 0001, 1011, and we have the typical read signal, write signal, reset signal, ground, power. So these are the typical pins are there also in the pin configurations. So the pins and ports usually in 8255, this is an example. This is an example where each of the ports, port A, port B, and port C, and the common register should have some specific port address. And already I've mentioned that port A and port B can be programmed as an 8-bit input or output port. In port C, each nibble, that means the upper nibble and lower nibble, that means the upper 4 bits and the lower 4 bits are programmed separately or can be programmed separately. And another thing is that why 8255 is a more versatile device, because due to its programming modes. So we have specifically 3 programming modes. I will show you today. But before going to that, how we make the interfacing. So let's have some discussion. Okay. So here is a mistake. This data bus should be 0 to 7. So here is this is the 8255, and this 8255 interacts with the outer world. So our input output devices are connected here, and this is our internal system, that is the 8255 is connected with the microprocessor through the data bus, and we have total A2 to A7, total 6 pins. You see that total 6 pins are there. That means in total 2 to the power 6 number of chips can be used in a system. That means in a single motherboard, we can maximum use total 64. 2 to the power 6 means 64. Total 64 8255 IC can be embedded in a single motherboard. So A2 to A7, these pins can be used to select a specific 8255. And next is the A1 and A0. A1 and A0 combinedly provides us 4 options, that the microprocessor interacts with which port that is mentioned by the A0 and A1. So 00 means it is interacting with port A, 01 port B, 10 port C, and 11 with the control register or control command register. So the same thing, so far what we have learned, that is the you see this is our data bus interacting with the microprocessor, and this is our ports, 3 ports, and we have the group A, we have the group B, and how the ports are selected, by the microprocessor through A0 and A1, the combination of A1 and A0, 00, 01, 10, and 11. So these are the 40 pins. Now the versatility of 8255. The versatility of 8255 is defined by 3 modes: mode 0, mode 1, and mode 2. So first of all, this is the command register format, the command register data, you can say, likewise 8155. But this command register has 8 bits, and out of these 8 bits, the most significant bit is always needs to be set to 1 to select that chip. So this field, this most significant bit should be always 1. And let's see that what is mode 0, what is mode 1, and what is mode 2. Okay, mode 0 is the for basic input output operations. Likewise, that we will use all the 3 ports, that's the port 0, port A, port B, and port C. All the 3 ports will be used for input output operation. Typically, we don't need any sort of handshaking signals, or we don't use any sort of handshaking signals when we use the 8255 in mode 0. This is like that all the pins of port A, port B, and port C will be used for input output operations. So no handshaking signals. This is mode 0. And the mode 1 is with handshaking signals. With handshaking signals means for input operation, we use the strobe signal and IBF signal. For output operation, we use the OBF signal and acknowledgement signal. So those are defined as handshaking signals. And if we use the handshaking signals for port A and port B, we say that this is mode 1. But one important thing is that in 8155 or in mode 1, we have to use the input output operation unidirectionally. The same port cannot be used for bidirectional input output. Can anyone tell me that is there any device that device will act as input device as well as output device? Anyone? Any idea? The same device can be used for input operation or output operation at the same time.
Sir, a recording device that can play the recording.
Okay, that actually nowadays we are using the touch screens, right? And we have some devices like printing and scanning. The same device can be used for printing and scanning, right? So while we are using for printer, it is printing as an output device, and while we are scanning, it is input device. Or the display devices, the touch screen display we are using while we are touching something that is acting as an input, and but the overall display is showing us the output, right? So in mode 1 or even in 8155, can we use the same port for those sort of devices? Can we use that? I guess no, right? I think it's no. The answer is no. As because the same port with the same port. So let's see the in 8155. I'll show you that. Let's see this port. This is equivalent of mode 1 of 8255 actually. So that is why I'm explaining it from here. The same port is connected with an input device, and we are sending the strobe signal. We are sending the strobe signal, and we are the keyboard is collecting the input buffer full signal. So only one input device is connected via port A. The same thing while we are connecting one output device, the 8155 is sending the OBF, and it is sending the acknowledgement and then collecting the data from port B. So we don't have any handshaking mode, or we don't have any sort of options or programming modes that through port A or port B we may connect those sort of device that can act as an input or output in parallel or simultaneously. So actually this is the mode. This is the mode 1 of 8255. In 8255, what we are telling in mode 1? In mode 1, we are telling that for a strobe signal with handshaking input output. That means no bidirectional option is there. But in mode 2, we can use the strobe bidirectional input output. I will show you that some example of strobe signal. So let's see the first, let's define the modes. Mode 0, In mode 0, what is happening? Ports A, B, C can be individually programmed as input or output ports. And port C is divided into two 4-bit ports for input and output, which are independent from each other. So you can use port C individually as a 8-bit input or output port, or you can use port C individually 4-bit input or 4-bit output, or you can use two devices, that two input devices having 4-bit inputs, or two output devices having 4-bit outputs. So all the options are there in mode 0, though we don't use mode 0. uh, Typically this is just an option. But in mode 1, what is happening? You see that let's write the group number first. Just a minute. In group A, what is happening? PA0 to PA7 and PC4 to PC7. These pins belongs to group A. And in group B, PB0 to PB7 and PC0 to PC3. These 4 pins belongs to group B. Now let's see that in mode 1, what is happening. Let's say one input device is connected through port A, and also one input device is connected through port B. Now, amongst the upper 4 pins of port C, we do use the strobe signals, likewise 8155. So see, the input device is sending the strobe signal through pin number 6 of port C, and then getting the IBF signal through pin number 5 of port C, and the pin number 4 is used to send the interrupt request signal on behalf of the input device towards the microprocessor. So this is the mode 1. At the same time, we are using port B for input device for connecting another input device, where this input device is sending the strobe signal through pin numbers 2 of port C and receiving the input buffer full signal through pin number 1 of port C, and on behalf of this input device, if any interrupt request needs to be sent to the microprocessor, in that case PC0 or pin number 0 of port C is used. And you see 2 pins of group A and group B, the pin number 3 and pin number 7 are used here as an idle pins. So we don't need those pins, though those pins belongs to group A and group B respectively. So pin number 3 is in the group B and pin number 7 is in the group A. So this is mode 1. And in this mode 1, we have used port A and port B for both for input device. But it might happen that the same in mode 1, this port A can be used for input and it can be used for output, for connecting one output device. In that case, the signaling will looks like this. The signaling will looks like this. How? That is that we have exchanged the input operations, and in case of output operations, first the OVF signal will reach to the output device, and the output device will send the acknowledgement signal, and on behalf of that output device, if any interrupt request signal needs to be sent, in that case PC0 will be used. So we have so many options that, or we can connect both the port A and port B for connecting output device only. So for connecting output device only, or connecting input device only, or one port is connected with an input device, another port is connected with an output device. So many options with mode 1, but we don't have any option here to connect a single device that may interact as an input as well as an output. So which mode we should use in that case? In that case, we have the option of mode 2. In mode 2, no longer the group is maintained. The group is not maintained. Rather, we can use only port A. And port A is programmed to be a bidirectional input-output port. You see that port A is used as a bidirectional input-output port, and port C, all the pins of port C is used for handshaking, and port B can be either input or output in mode 0 or in mode 1. So you see that for port A, what is happening? If the, at the same device, if we use, say, let's say we have used one device that can do printing plus scanning. The same device can do printing and scanning. And if we, while printing or while scanning, the device will send a strobe signal, then we'll get the IPF signal, and we'll place the data into port A's data line. Or while printing, this is we are doing while we are scanning anything. So this is working as an input device. At the same time, if we do need to print anything, in that case, the OVF signal will reach to the device. It will send the acknowledgement, and these two pins of port C will be used for printing. For exchanging the print handshaking signals. But for the whole port A, we don't need two separate interrupt request pin. So that is why only port C is used for sending the interrupt request signal. And you see that as we are claiming that port B, in that case, the port B can be used for input or output, or it only in mode 0 or in mode 1. That means port B cannot be used for bidirectional input-output devices. So in that case, for port B, we can either use it for input operation or output operation. So the modes are defined. So in mode 0, we can use the port B. In that case, no handshaking signal is required. So that is why in or out operations are there. And in mode 1, if we use the port B, in that case, in mode 1, for input operation, the strobe signal, IBF signal, and interrupt request signal, or OBF signal. In output operation, OBF signal, acknowledgement signal, or interrupt request signal. And for that, for exchanging their signals, we can use the pin number PC0 to PC2 of port C for exchanging the strobe, IBF or interrupt, or OBF acknowledgement or interrupt in mode 1. And in mode 0, we don't need to use those 3 pins, because in mode 0 we don't use any handshaking signals. Have you got the definition of mode 0, mode 1, and mode 2? Any question regarding mode 0, mode 1, and mode 2? Okay, so the definitions I have already given. Now let's see the control word format. The control word format, that is the control word of command always. The command byte has the 8 bits, and the command always provided by the microprocessor, and the command is stored into the command register. Now let's see. Let's start with this 8-bit command byte for the 8255, and already I have mentioned that the 8th bit or the MSB bit should be set to 1. And let's start with the LSB. LSB 0, the bit number 0, if it is pointed with 1, that means all the 4 pins of group B belongs to port C, that PC0 to PC3 will act as an input. Or if it is 0, these 4 pins will act as an output. But still, I have not defined the mode for port C. Next, or for group B. Next, port B, the same, 1 for input, 0 for output in bit number 1, you see. But in this case, we are defining the mode of group B. The group B, all the pins of group B can operate either in mode 0 or in mode 1. So you see, if bit number 2 is having 0, that means the group B is working in pure basic input output operation. Or if it is 1 in mode 1, group B is working in mode 1, that means that all the 8 pins of port B is connected with an input device or output device, and the handshaking signals are sent through port C. The handshaking signals are sent through port C, the lower 4 pins of port C. Already I have shown you the example that you see that the lower 4 pins are used for either for output operation or for input operation. So this is our mode 1. This is our mode 1. But in case of mode 0, so this is just an option. In that case, we can use all the 8 pins of port B for input or output, and all the 4 pins of port C, that those belongs to group B, can be used for input or output. Now, let's up to this we actually define we actually defines group B. You see, group first of all, you should understand that which pins are grouped together for group B. Again, I am defining all the 8 pins of port B, that is PB0 to PB7 and PC0 to PC3. Those belongs to group B. Now, next is the group A. For group A, what is happening? Let's see that with bit number 3. Bit number 3 defines the port C's upper 4 pins operation for input or output. If it is 1, those 4 pins are used for input operation. Otherwise, it is output operations, and it is used for output operations. Next, bit number 4 is defining the port A's operation. If it is 1, that means all the 8 pins of port A is used for input operation, or otherwise it is output. It is used for output operation. Now here is the complex part. Bit number 5 and bit number 6. Those actually defines the mode 0, mode 1, and mode 2. Can anyone tell me why in mode why group B is working with 2 modes, whereas group A is working with 3 modes? Can anyone answer? Or I can pick one today. At least I can ask someone. Ahmed Ejaz Hamdun, are you there? Ahmed Ejaz Hamdun, are you there?
Sir, can you hear me properly?
Yes, I can hear you. So can you tell me that why group A has these 3 modes, whereas group B has 2 modes? Can you tell me that? Yes or no?
Sir, I'm not sure, sir, about that.
But any guess, or who can answer it? Anyone who can answer it, just raise your hand. Can anyone answer it that why more three modes are used for group A, whereas two modes are used for group B?
Sir, in mode group A, sir, it can be used for mode 2, that is for input output,
Right.
bidirectional.
Yes. Whereas in mode group B, in that case, the definition is already mentioned here. Only port A is programmed to be bidirectional input output port. Whereas at that time, port B can be either input or output, but cannot be used simultaneously. So this is the definition of mode 2. So that means surely, surely group B, that means in group B, who are there? Which ports are there? Port B and port C. So surely port B and port C cannot be used for mode 2. So that is why group B, for group B, we have defined only mode 0 and mode 1 through the bit number 2. Whereas in port A, we can connect bidirectional input output devices, and in that case, port A or group A need to be work in mode 2. So that is why we defined uh, 2 bits. By using 2 bits, we are defining the modes. Purely 00 means group A is working it pure mode 0 mode, that means no handshaking signals. All the 8 pins of port A either used for input operation or output operation, and the upper 4 pins of port C either used for input operation or output operation. If it is 01, if it is 01, that is the second option. That means port A either used for input or output operation, but of course we need to use some handshaking signals through port C's, these 4 pins, PC4 to PC7. And if it is 1x, x is, you know that x you use for don't care condition, that means either 10 or 11, whatever is the value of this bit, 1x, that is 10 or 11, whatever is the value, we are defining port A as a mode, as a port where we have connected some device that may perform input and output operation. And for exchanging the control signals, we have to use the port C. How? So the example is already defined. That through port A, we can simultaneously done the input output operations, and through port C, we can exchange the handshaking signals for port A. At the same time, we can use port B for either for input operation or for output operation, either for mode 0 or for mode 1. But in that case, for mode 1 only, we have to exchange the control signals through these specific 3 pins. So no longer we can use the group B's uh, PC3, because PC3 belongs to group B, but in mode 2, PC3 needs to be used for port A. So this is the difference. So I guess the definition of mode 0, mode 1 and mode 2 is clear to all of you, or you can study later. And then if you have any question, then you can ask me in the next class. Now, this is the uniqueness of 8255. So that is the thing they have claimed that is the thing that what make 8255 a versatile device is its programming modes. Though what is the uniqueness? The uniqueness is that it can connect some bidirectional devices for input output operation, or it can use the handshaking signals. But for handshaking signals in 8155, we haven't used any sort of grouping. Rather, here one sort of grouping or some structured programming or structured way is defined for 8255. So this is the uniqueness of 8255. Now, I will talk about the timing diagram, then I will finish the class. So for mode 0, we don't bother about the timing diagram, but for mode 1, we have to use some timing diagram. So let's see. So mode 1, so this is the first one is uh, in the first one for port A and port B, we use only for input operations. So you see, At the very beginning, you see the timing diagram. So this is the earlier time and this is the later time. So the time is increasing on the right side. So at the very beginning, whether we use port A or port B, whatever we use, the strobe signal needs to be sent first. When strobe works with logic low signal, you see the strobe signal is coming first. And after getting the strobe signal, and the strobe signal always provided by the input device. And after getting the strobe signal, one IBF signal is coming towards the input device. This is for port A, this is for port B, the same strobe signal, then IBF signal. And even after getting the data, you see the data is available from the very beginning. This is the port data, the data line, PA0 to PA7 or PB0 to PB7. So this is the timing diagram both for port A and port B. And you see that, so let's consider only for port A. So this is port A's PA0 to PA7. So this is the definition. Now the data is available after making the data available in the port line. The input device is sending the strobe signal. Here is the strobe signal. This is the strobe signal. And after that, the 8255 is sending the IBF signal, buffer full signal. If the buffer is full, in that case, the input device is waiting. So in that case, the 8255 will send one interrupt request signal through pin number PC3. PC3, and this interrupt request is sent towards the microprocessor. And let's say if this interrupt request signal is processed or even not processed, let's see the buffer is empty. The buffer is empty. So after sending the buffer full signal, in that case, the read signal will be sent by the microprocessor towards the 8255, then it will collect the data. And the data is read by the microprocessor. It will collect the data. In this case, the data will be collected by the microprocessor from 8255. So these are the step-by-step input or output operation. Even if you consider this port A, this is PB0 to PB7, still the same scenario is happening. One input device is connected into the port B, so it needs to send the strobe signal. If we omit this one, so let's omit this one in this case. Let's say the input buffer is empty. In that case, if the input buffer is empty, in that case, the IBF signal will be always in low signal. That means no buffer full signal. If it is high, if a logic high signal is sent through PC1, in that case, the buffer is full. We mean that. But if it is low, that means the buffer is empty. And in that case, the 8255 will collect the data from the PB0 to PB7, and afterwards, the microprocessor will collect the data by sending one read signal. So these are the step-by-step procedure for input operation in mode 1. So let's see what is the step-by-step procedure for output operation in mode 1. You see, both the directions are towards outside. That means some output device is connected. So you see that at the very beginning, the microprocessor needs to write the data. The microprocessor needs to write the data towards the 8255. Even for port A or port B, whatever port we are using, the write signal needs to be performed first. After that, if we use any interrupt request, so in that case, interrupt request can be used or we can omit it. But after that, the OBF signal is sent towards the output device. And after that, the acknowledgement signal is sent towards the 8255 by the output device. And the data is available into the port, data is sent to the port here in this position after performing the write operation, not before the write operation. Earlier, the data was available from the very beginning into the port as because we are performing input operation. But in this case, for output operation, the data is available from here. And after that, the data will be available. And from these data lines, or from the 8255 data lines, the data will be collected by the output device. And this is applicable for both for port A and port B. But one thing, we can't use port A and port B simultaneously for input and output operations at the same time. So what do we need? We need the programming modes of mode 2. In that case, I haven't used the timing diagram. Rather, we say that this timing diagram is a combination of mode 1 strobe input and mode 1 strobe output timing diagram. So you yourself can draw it. So it can be considered as an assignment to you. So please, or you can study on it. So I may take one assignment on this particular lecture, but later on I will give you the assignment before the midterm. It will help you for the midterm questions as well, or midterm study as well. So one assignment will be given to all of you to derive the timing diagram of mode 2. Here is the timing diagram of mode 1. This is for output operation. This is for input operation. But what timing diagram is there for mode 2? This timing diagram is a combination of mode 1 and mode 1 strobe input and mode 1 strobe output timing diagram. Then you will get the mode 2's timing diagram. So I have kept it reserved for the students for assigning one assignment. So that's it. It's 9:50. I have finished this lecture. So lecture 5 is up to lecture 5 we have completed. Hopefully I will go up to lecture 7. In lecture 6, I will discuss about the programmable interval timer. And in lecture 7 is a bit theoretical, that is related to introductory lecture about embedded systems. Okay, the attendance is not that much good today. And at the very beginning, only 11 students were there. But gradually the number is increased. From next on, I may check that. So any question? And on next Friday, we will have the class test. Akib, are you there? Akib Mahmood. Yes, seems you are there. Akib, can you hear me? Okay, our class test time is at 2, most probably at 2 or 2:10, right? Both the groups will have the class test at the same time. And we have the regular classes with you guys. I will have the class at most probably at 2:30 after the class test. So see you at 2:10. Both the groups will have the class test at 2:10 on next Friday. And today we will have the lab, right?
Yes, sir.
Yes,
Okay.
sir.
Okay, today at 3:10 we'll have the lab. So I have some instruction to you that please go to your class test, Google Classroom, and where I have uploaded the Proteus software, and in your regular theory class and lab classroom you will find this. Download it. Then after downloading, please follow these steps. To install it so that we can start the lab at our earliest possible time at 3:10. Okay, so see you in the lab. Okay. Allah Hafiz.
Sounds, sir.
Assalamu alaikum.